Greetings. Welcome to my talk on Towards an Evolutionary Architecture. My name is Venkat Subramaniam. Thank you so much for joining, and thanks to the conference organizers for inviting me as well. Well, I'm going to talk about three different things in this talk. I'm going to talk about architecture and why should we really evolve architecture. Then the second part, I'll talk about what are some of the risk of evolving and the risk of not evolving architecture as well. And then most of the talk, the third part, I'll talk about some principles and practices we can follow to attain evolutionary architecture. So let's get started. Well, the first question I would start with is, what is architecture? Well, I encourage you to answer that question in your own mind. Go ahead and try it. What is architecture? Oh, that's the first answer I hear all the time. Architecture, you just defined, is something you kind of feel, you know what it is, but you cannot put into words. Good definition, by the way. Let's go to the second definition. What is architecture? Well, that's one of the problems. We all kind of know what architecture is, but really becomes hard to put that into words. Some people say it's a blueprint of our design. Well, then what's different between architecture and design? Some people say it's an interconnection of components. Sure, but that's in the design as well. Well, it turns out that's a question that a lot of people have in their mind. And Martin Fowler wrote a really nice article. I always encourage people to read it. If you haven't had a chance to, please Google for it and look for the article named Who Needs an Architect? Really brilliant article, a very short one, about 3.5 pages long. So just Google for Who Needs an Architect? Well, the Who Needs an Architect talks about architects, but it also raises the question of what architecture is. And Martin Fowler gives a definition, and he says he doesn't like the definition, neither do I. And the definition that a lot of people use is, architecture is a set of decisions that are really hard to change. I'm not a fan of that definition, because I can create a lot of stuff that are hard to change and celebrate I've created architecture. So there's got to be a better definition of what architecture is. Well, it turns out that he invites other people to comment. And one of the people who wrote back was Ralph Johnson, one of the co-authors of the famous Design Patterns book. Well, Ralph Johnson says architecture is a knowledge, a shared understanding of the most essential parts of a system. What I really like about in the definition is two words, shared and essential. Well, the essential parts of the system is very important to focus on. Leave out the esoteric things for later. And it's a shared understanding. So architecture is not something that's kept in the ivory tower. It's not something that's kept among an elite group of people. It's got to be common and practiced and shared understanding of the system by the developers and people involved on the project. So, okay, we can create architecture. Architecture is this understanding of the system, how we are going to build and develop. It's a higher level definition than a design itself. But then why should we really evolve architecture? Let's think about this for a minute. I'm going to ask you the question, is architecture important? You probably are nodding your head and saying, oh yeah, it's important. Well, how important is it? Oh, very important. You better not get it wrong. Totally. Well, if architecture is important, I think we can all agree that it's important. When do we normally create architecture? Well, let's think about a timeline, if you will. If that's a timeline we have, typically, we could say architecture is created in the beginning of the timeline of a project. Well, sometimes in the beginning, sometimes even before the beginning. I had a client of mine call me up and said, hey, we're going to start on a project. I want you to be involved in it, but can you help us with it? And they said, it's got to run on the cloud and it's got to support concurrency. I said, got it. And they said, no, you need to really understand. It's got to run on the cloud and support concurrency. I said, can you tell me more about the product? And they said, well, we don't know yet, but we know that it's got to run on the cloud and it should support concurrency. Well, sometimes we make architectural decisions even before we get down to deciding what the particular product is going to be. But I think most of us can agree that the timeline of a product development is this. In the beginning, well, on the y-axis is the knowledge we have of the product and the requirements. And of course, the x-axis is the timeline. I think we can agree that in a development process, in the beginning, we don't have a clue. Sometimes we think we do, but mostly we don't. And right about 40% into it, things begin to fall in place. We begin to understand. And then, of course, towards the very end of it, most of the things are fairly clear. Well, I used to work for a gentleman and he used to call this RAD. I'm sure all of us have heard the term RAD, isn't it? Well, you're probably thinking, oh yeah, of course, it's rapid application development. Well, sure, but he used to call it requirements after delivery. Well, you're always right if you define the requirements after you deliver the product, isn't it? So the point really is that we don't understand a lot of stuff in the beginning. Now let's put these two ideas together. We just said architecture is often created in the beginning, but we also said we have the least clue as to what we are doing in the beginning. So now this is predictably irrational to really create something that's that important when we have the least clue what we are trying to actually build. So the point really is there is a risk in creating architecture in the beginning. But of course, as an architect, you are thinking, oh, come on, I've got a job to fulfill. My company wants me to deliver the architecture. What do I tell them? Well, the point is to be truthful, to be realistic, to be genuine, and to say that, no, I cannot create an architecture in the beginning. I have a vision for the architecture. I'm going to work with the team to create it. But what I can develop in the beginning is an architectural vision, a draft, and we're going to evolve this architecture in the first several sprints of the product. Maybe what we can do is take the first 3 or 4 or 5 sprints on a project that's going to run longer, obviously, and be able to create the architecture during that phase, during that period of time. But what is the risk of not evolving the architecture? There are two problems in not evolving the architecture. Well, if there's an architectural group or a committee or even a single person who's creating this architecture disjoined from the code, then what happens is these architectures have been developed with some vision, some idea that originally people thought about, but it's not tied down to the realities of the project and the code and the business. Well, oftentimes, unfortunately, in companies, there's a group of architects I fear the most. I call them the PowerPoint architects. Well, the PowerPoint architects know to draw pretty pictures on the PowerPoint, but cannot really do anything practical. And they often leave behind a disaster architecture for the team to maintain in the long run. Well, when such things happen, there are two possibilities. One, the team may soldier down and implement the architecture driven down by the architectural team or the architect towards them. And as a result, they're forced to implement that architecture, and the code and the architecture deviates from the realities of the business, and the product eventually may fail or at least suffer the long consequences of not being able to maintain. On the other hand, it is quite possible that the architects, the PowerPoint architects, don't really understand or look at the code. The team may be really working on the code as they evolve it, but they may have pretty pictures on the wall. And of course, when the architect walks in, they may close the monitor and look at the wall for the pictures. In that case, the code doesn't represent the real architecture, and the architecture doesn't unfortunately serve any purpose other than saying there's an architecture. So in other words, the biggest problem with risk of not evolving architecture is relevance, if the architecture is going to stay relevant and be useful for the product. But let's not be naive about it. There's a risk of not evolving, but at the same time, there's a risk of evolving architecture as well. What could be the risk of evolving the architecture? Well, one of the biggest risks of evolving architecture is, what if suddenly we find out that as we are evolving the architecture, it doesn't meet the requirements? There's a misalignment, and we realize we got to go back and change drastically a lot of things in the architecture. Well, that just sends shivers through our minds, isn't it? Because that's could be a disaster in the making. How do we deal with it? Well, first of all, there are a couple of things to really keep in mind. One of them is never build architecture, if you will, in horizontal layers. So if you build it in horizontal layers, then there's a huge risk in developing the architecture. So if, let's say for a minute, we have come up with an architecture where we have multiple layers of this particular architecture. Well, teams have done this in the past where once they develop this architectural vision, they say, great, we got work cut out for ourselves. We're going to spend the next month building this layer. And when we are done with it, we'll come back and build that layer. And then when we are done with it, we'll come and build that other layer. Well, the problem in this case is that over a timeline, this has been distributed across where we finish this particular layer, and then across the timeline, we start building the next layer potentially. And then this could be deferred over similarly and so on. Well, the problem of this approach rather is that it's a huge risk in general. The reason this is a huge risk is that when the teams are building this kind of architecture, by the time they come to build this part, they realize that some of the decisions that they have made here is totally irrelevant and it doesn't quite match up. So how do we really deal with this situation? Well, one way to help with this is never to build it in horizontal layers, but instead to build it in vertical layers. So in other words, we take this particular architecture, but build a chunk vertically based on what is relevant to the current set of features we are working on. And then once that is done, then build the next part into it, and then the next part, and then build them in vertical slices. So that is one thing we can do to mitigate the risk of evolving. But again, how does it really help mitigating the entire risk? Well, the risk it mitigates is the non-alignment of different parts and going on a tangent and building one particular piece and realizing that's not really that important as we thought before, or maybe not even needed. But also on the other hand, when it comes to project, we often work with user stories. So we have a story 1, story 2, story 3, and so on, different stories. What the question really is, how do we implement these user stories? Well, when you take this pile of user stories to chop them into multiple sprint backlogs and then saying that's for the sprint 1, that's for the sprint 2, doesn't really help. Instead, what you want to do is to take these stories, but you want to look at these stories from 2 different angles. One is look at the business value of these stories. Are some stories more valuable, for example, than other stories which are maybe not as valuable? Maybe this one has a value of 10, which is very high, versus this one has a value of 7 from the business point of view. Whereas this one has a value of 4, maybe this one has a value again of 10, and so on. And you have these stories that are of different business values. Second, take a look at the architectural impact of these particular stories. Some stories may have a very high significant architectural impact. Other stories may not really have so much of an architectural impact. They may just fit in really well with most of the common internal implementations in different layers. So if this has an architectural impact, let's say of 8, whereas this has an architectural impact of, let's say, 7, whereas this one has an architectural impact of 3, let's say, and on the other hand, this one has an architectural impact of 10, and so on, and we can look at these different values. Now, when it comes to your project backlog, you don't want to just chop them up into pieces and start implementing them. Instead, take on the stories that have the most business value and the most business impact at the same time. The stories that have least business value and least impact, keep them for later. So in other words, start with the most important and the most impactful stories in the beginning and work towards the less important and less impactful stories later on. Well, if we do this, there is one problem though. And the problem really is that when it comes to doing this, we will go a little slow in the beginning because we're trying to do the most important things and the architecturally important things as well. And that may take a little bit time, more effort as well. Well, is that a concern in projects? Well, I would argue, if you ask me, there is one word I dislike the most in the today's industry on agile development, and that is called velocity. I truly dislike this word velocity because developers and teams seem to jump on this bandwagon of velocity, and it really is something that messes up with the ability to focus on the delivery of quality products. Well, velocity is not important to me because the reason I emphasize that is in the beginning, if I want to really show a higher velocity, I may have to do easy things and simple things. So what is the point in me showing a greater velocity in the beginning? Because when the time really matters is towards the end. I don't want to delay things in the end. I want to actually do easy things in the end and less important things in the end, so we can compromise on saying, hey, we have done the most important essential things. These are less important, so we can, vary the scope and still deliver on time that we have decided. So the point really in this case is you really want to take on the high business value and architecturally impactful stories in the beginning and leave the rest to the later time. So schedule your sprint in a way that you work on the most difficult things and most important things in the beginning. Now, how does that really help with mitigating the risk of evolving architecture? Well, the way it really mitigates the risk is you have worked on the most important things by the time you come to the seventh sprint. And in the seventh sprint, you realize you need to implement something that doesn't fit really well. Keep in mind, those are less important compared to what you already have done. Well, in that regard, there is one thing we need to still consider. There are two kinds of backlog features you could think about. Those that are planned, things that we know that we're going to implement, and then those that are surprise features. Maybe one of your consultants or salespeople is attending a conference and they make a frantic call telling you, oh my gosh, we really need to implement a feature because our competition is implementing it. And if we don't, our product is dead in the water. Well, so you're going to ask this feature to be brought in. How do you deal with such a surprise feature to be brought in? What if that surprise feature doesn't fit into your architecture? What do we do? Well, in the case of planned features, things you already know, we could use the approach I outlined here in terms of taking on the high priority ones, business value-wise, and architecturally impactful ones. But what about the surprise features? Well, the surprise features are going to come and knock on the door irrespective of whether we are evolutionary or not. So in that regard, we need to still implement them. But my argument is, if we do practice an evolutionary architecture using some principles we'll talk about here, we'll be much better off accommodating those surprise features as opposed to not doing it. Now, in that regard, when it comes to evolving products, we really need to focus on prioritization based on the architectural impact and on the business value of the application. Well, one of the challenges also in today's world, before I move on to the topic of some practices, is how we carry out design. Well, in the past, most of us did waterfall development. Now, we frown upon waterfall these days. If somebody comes to you and says they do waterfall development, maybe you'll sit a little bit away from them, leaving a seat vacant. We always practice social distancing with people who follow bad practices or poor practices, isn't it? No, just kidding. But the point really is that what is wrong with waterfall, or what was wrong with waterfall? Now, what was wrong with waterfall is we did big upfront design. And so we would go design the heck out of the system and architect the details before we start actually coding. Now, today's world, we're all agile, isn't it? What a wonderful time to be in. But what does it really mean, agile? Well, I go to organizations, I'm a consultant, I work with a lot of different companies, and when I go in, a lot of them will tell me, oh, Venkat, we want you to know that we are agile. And I always tell them, I'm so glad we can get that out of the way. Now let's talk about what you actually do. Unfortunately, a lot of companies call what they do as agile, but what they actually practice is waterfall. They call it agile because it feels really good, but what they do may not really be agile at all, or not to the full measure to get the benefits out of it in that sense. So what does it really mean to be agile? Well, to me, really being agile is being adaptive. That is the first thing. It is to be adaptive and to drive the development based on the feedback. So if we are not being adaptive, if we are being pedantic about the schedule and the scope in the beginning, if we nail the architectural details in the beginning, then how could we say we really are agile? Because the whole essence of agility is to be adaptive and drive the development based on the feedback. So when it comes to agile development, unfortunately on a lot of projects, we don't do enough architecture or design for that matter. And then we say, don't worry about it, we'll figure it out. We work on the sprints and then we say we're agile, we'll get to the details eventually. Well, the problem with big upfront design is not the word design. not even the word upfront. The real problem is the letter B, the big in the big upfront design. What if we can do, instead of the big upfront design, what if we can do enough upfront design at the beginning of the project to come up with a vision of what we're going to do? At the beginning of each sprint, what if we can spend a little bit of time with the design and the approach we're going to take? What if we have an architect who works as a foreperson and walks around the team and helps people on the team and converge them towards an architectural vision, and at the same time evolve and ratify that vision along the way as well? So the point really is we need to really rethink about how to bring architecture in an agile setting, in an agile project. Well, the difference between just hacking or doing stuff randomly versus being evolutionary is where we follow a set of practices and methodically and deliberately move towards evolving the architecture. So I'm going to talk about some practices we can follow in the next about 30 minutes or so we can think about how we can manage the evolution of the architecture. The first thing I'm going to talk about is, first of all, keep it simple. Now, of course, we can be very dismissive of this and say, oh, come on, everybody says keep it simple. It's kind of obvious. Well, yes, it's true that everybody talks about keeping simple. But the problem really is, unfortunately, most of us don't know what simple really means. I'll pose a challenge to you. Walk around the building or to talk to your colleagues and ask them to define what is simple. I bet you will get as many definitions of what simple is as the number of people you ask. Go ahead and try it later today or during the week. Just when you meet technical people or business people, ask them, hey, do you think we should keep things simple? Oh, yeah. And can you tell me what simple is? And just note down what their definition is. If you're really interested, my email address is on line number 3. Drop me an email and let me know. I'd be delighted to hear what you find out from that little experiment. What do you hear people say simple is? I remember working on a project in Poland, and I was talking to the developers and I was telling them, gosh, this design is so complex. And after a few minutes, they looked at me and said, we don't understand. You keep saying it's complex. We all collectively think it is simple. And I said, oh my gosh, how could you say this is simple? And they said, look at the code. All it contains is a very simple if-else statement. Why do you keep saying it's complex? And that's when I understood we don't really understand what simple really means. What they had was 70 of those if and else structures in a function, and that duplicated in multiple places. So this code was violating a lot of design principles, and the complexity was in the duplication of all the simple logic repeated over and over, and the code was not extensible because of all the decision making spread out in so many different places. So we all agree that things should be simple, but we don't quite know what simple really is or to even recognize it. So to me, an architecture is simple when it has the fewest moving parts. And well, you say, gosh, did you just say fewer moving parts? What about microservices? Yes, keep in mind, nobody ever should claim that microservices are actually simple. Quite the opposite. Microservices are one of the most complex things out there. Now, that is not to say we should not use them. That is to say that we should be really deliberate and know that that's the right answer. For a lot of applications, microservices is not the answer because it's not simple, among other things. It's more costly to build as well. If it warrants that kind of complexity and the cost, microservice might be the right choice, but if not, maybe not. And in fact, it's not a bad idea to start with a monolith and ease into a microservice, even if it makes sense. And even if a microservice were the right solution, maybe to limit the number of microservices to a very few in the beginning is a prudent solution. So in other words, at various degree, we need to think about simplicity. But what in the world is simple? I keep using the word, you say. Well, simple has fewer moving parts in it. Simple is easier to understand. Simple fails less. But when it fails gracefully. Simple is something that is easier to evolve. Simple doesn't have unnecessary details in it. So we can work towards simplicity in every single step of the way. So to be able to evolve an architecture, we want to keep it simple. Well, Ralph Johnson, the author of the Design Patterns book I mentioned earlier, once said, we create hierarchies of classes and interfaces and such, and we do that with the hope, with the expectation that we can make the code extensible. But he goes on to say, but in the long run, the very thing that we will set out to build for extensibility comes back to haunt us and make it really hard to extend. Well, that's the exact problem with architecture as well. When the architecture is really simple, it becomes easy to come in and make changes to it. When the architecture is complex, it pushes us away from the change and the change becomes expensive. So if you really want to make a change in the future, you want to work hard towards making things simple so the change becomes affordable in the future. On the other hand, if we have built complexity into something, it becomes really hard to extend it. The next thing to keep in mind is to refactor. Now, it is not possible for any human to create something correctly in one sitting. Software is never about writing. Software is always about rewriting it. So we need to be able to create something and refactor. In fact, it's so much so that even in test-driven development, the mantra is red, green, refactor, red, green, refactor, red, green, refactor. So even the architectural level, that refactoring is extremely important. And there are approaches like tracer bullet approach that we can use to tease out and prototype architecture and then evolve it and refactor it along the way. And so refactoring is something we have to do continuously. And refactoring, if you really think about it, very many industries do this all the time where they do something and then they come back and clean it up and then tidy it and then evolve it. And the software field needs to do this more often where we prototype something, we build something, and then we come back and make changes to it. So the external behavior is the same, but the internal structure is a lot better. So continuous refactoring should be something we do every single day. Now, refactoring is not something we should shy away from, but to be able to embrace it. And I always say, refactor your team's code and rewrite your own code. And that's one of the courages we need to have. When we are building something, we realize, hey, I really don't need to use so many complex solutions and libraries and dependencies. I'm going to refactor this to remove a lot of coupling and reduce the number of packages that I'm using. Well, that's an architectural decision you may have to make and be able to entertain the thought and work with the team in order to refactor it becomes very critical. When it comes to making decisions, one of the factors to really think about is called reversibility. So what is reversibility? Reversibility is our ability to back out of decisions. So you make a decision today, but in 30 days from now, in 60 days from now, in 3 months from now, you realize that's not a really good decision and you want to be able to back out of it and make a change to it. So when it comes to sitting down and creating architecture, I often ask my team, how reversible is a decision? If a decision is reversible, I make the decision a little lightly. If a decision is irreversible, I will spend more time and effort before I make that decision. Let's take an example of a few things. Programming languages choices are often irreversible. Why is that? Well, it would be ridiculous for me to walk into your organization and say, you shouldn't be using that programming language anymore, you should use something else. Well, a lot of code written in that language is incredibly hard to throw away and rewrite in a different language. That is not to say we don't want to mix programming languages. You could be mixing C# and F# on a project. Absolutely. You could be mixing Java and Kotlin or Scala or Groovy into a project. That's perfectly fine. So you can bring in different languages into a project, but throwing away existing code written in a language and using a completely different language is rather impractical in most of the projects. So reversibility, language decisions are largely irreversible, but we need to make that decision very thoroughly and not make on a whim. So we need to really be focused on asking how really determined we are with this language. Have we considered all aspects that we could think about? On the other hand, something like a database or an XML parser may be reversible. You can decide to use a different database tomorrow as long as you can have a compatible driver to it. Or you can decide to use a different parser, if you will. But in any case, though, there are a couple of things to really consider. Just because something is reversible doesn't mean it actually is reversible. For example, if you have a lot of stored procedures, it may be hard to reverse out of the database that you are using. In the same token, when it comes to reversibility, we need to keep in mind that frameworks are really hard to reverse compared to libraries. If you ask me what keeps me in the wake in the night, it's not the libraries that I use, but it's the frameworks I use. You use the library, but a framework grows around you. Well, how do you really deal with frameworks? You want to minimize them for that reason, because frameworks are tight coupling and really hard to reverse. But what about really using libraries? Well, libraries are much easier to reverse, but if done really well. And for that, I would encourage teams to architect and design to keep the surface area really small. What do I mean by surface area? Suppose this is the library that you are using, and if this is the code, if your code depends on the library, it becomes really hard to replace it. So the surface area is really big, your contact point is very large. On the other hand, if this is the library your product wants to use, you implement an adapter that talks to the library. Now you have a body of code right here, but the body of code goes through an adapter. Well, tomorrow if you want to replace it, you just have to affect the little area of contact and replace it. So by reducing the surface area, by introducing facades and factories, or rather adapters, you can reduce the surface area and make application easier to reverse. Well, when it comes to design decisions and architectural decisions, I often sit with my team, and while we are making the decisions, I often ask them to think about reversibility and document it and say how easy it is to reverse something versus how hard it is to reverse something. Things that are hard to reverse need to be postponed and evaluated more thoroughly than the things that are easier to reverse. And keep your surface area really small so it becomes easier to evolve your architecture and extend it later as well. One of my favorite approaches is called the last responsible moment. Last responsible moment says you want to postpone making a decision until it cannot be postponed anymore. Now, obvious question here is, why should we do it? Well, that's because we are smarter tomorrow than we are today. We know more things tomorrow than we do today. And so as a result, we want to really postpone decisions until a later time. I'll share with you an experience I had with this. I had a 6 months period to develop an application. It was a time-bound project. At the end of 6 months, it's got to be released. The scope was a variable. I have the wiggle room. I took the most important things at the beginning, left the less important things to later time. Now, in that case, of course, when I started the first day, it's a foregone conclusion I need a database. But I said to myself, no, I am not going to use a database because I don't know the schema yet. The schema is going to change along the way quite a bit. So I decided to use SQLite 3 as the database. That's not really sensible. You would not put into production, but that's exactly what I decided to use. And I had a SQLite 3 as the database for 4 months out of the 6 months of development. Now you may say, gosh, why did you wait that long? For a few different reasons. One is SQLite 3 file-based database was easy to blow away and recreate as I was evolving the schema. The second reason I did that was that we had to deploy this application on the cloud, but we didn't have a clue which cloud service we're going to put that on. And that had an impact because depending on where we're going to deploy, the databases we use may be different. So I wanted to wait until we made that decision before I committed to a database. Well, at the end of the 4th month, I was in a panic because we have not decided what database to use. And once we found out what cloud we're going to deploy in, and I knew very well what we're going to use, I came in and made the change to the database. And I remember that day very fondly. I had all the tests running. I make the change to the configuration, run the test, and 3 tests failed. And that moment is a moment of panic. I'm like, Mom, I need help. I don't know what to do. That kind of panic moment. And I said, calm down. I'll be honest about it. I just copied the error that I got in the console of the test, pasted it on Google search, and the first entry on Stack Overflow said, hey, if you get this error, your database field format is incorrect. I'm like, I can handle that. And I went back and I rolled back to the old database I was using, ran the test it was passing, modified the change of the data type, ran the test again in the old database, that still passed, made the change to the newer database, ran the test again, it passed, and I walked away, never looked back after that, one stop moving, and I'm done. So last responsible moment gives us the agility to postpone the decisions when we have more information points. Now, of course, it made me realize one thing though. We all talk about last responsible moment. It took me a while to realize it. Maybe a year or so later, I was thinking about it. Maybe I was speaking in a conference. I realized, oh my gosh, one of the reasons I was able to practice that is I had a solid amount of automated tests. You remember the 3 tests that I said failed? Those 3 tests were actually in one part of the application that is not used too often. And in fact, once the application goes into production, customers using the product may not get to the point for several weeks, if not months, as they start using the application. Can you imagine not having that ability to run the automated test? A ticking time bomb would be sitting inside the code. So agility, again, if you really want to postpone things to last responsible moment, you cannot achieve that with manual testing. So having automated testing contributes to agility and ability to evolve the architecture. So in other words, if you want to evolve your architecture, having a decent amount of automated tests becomes extremely critical, as I realized after the fact in this case, but thankfully in the right way. Well, the next one is the Agni Principle, which stands for you aren't going to need it. I can't tell you how many times I run into this with developers. I often say, Agni, you don't need it, you don't need it. Sometimes developers get apprehensive. They say, what if we need it? What if its extensibility depends on it? So I tend to put a little Y in the end, which stands for you aren't going to need it yet. And they say, oh, so it's not yet, so I can maybe wait for next week or next day. And then we keep postponing it until we release the product without it. But the point really is you are not going to need it. So we bring in, I can't tell you how many times I've seen developers bring in code and bring in components into architecture. And I ask them, why do you need it? And they look surprised and say, because we need it. It's like, no, you cannot answer the question, why do you need it, by saying we need it. Give me a reason why we cannot live without it. And Agni, you're not going to need it. Postpone that until you can prove that we cannot really develop this application without it. Because the code we did not write has the least amount of errors in it, hands down. So the less complex application, the fewer components, the fewer dependencies really help us to build better application. So keep asking that question, why do we need it? Why do we need it? And then only if you cannot really run the application without it, then bring in those dependencies and implementations. But wait a minute, what about extensibility though? Don't we want to make the code extensible? Sure we do. But one of the problems is, in the name of extensibility, we bring in so much complexity. And in doing so, we make it really hard to extend the application in the long run. I can tell you how many times I worked on applications where there is hundreds, if not thousands of interfaces built for extensibility, where they actually make the code hard to maintain in the long run, rather than actually making it easier to extend. Well, the problem with extensibility oftentimes is what we think is extensible now may not be the reality when the extensibility actually shows up and knocks on the door. There are 2 ways we can actually work towards it. One is, I'm a big fan of this approach called Parsimony. Parsimony is where we keep the minimalistic design, minimalistic code, minimalistic architecture. So parsimony is fewest elements, minimalism. Hey, let's only go with the bare minimum and keep everything else away and justify the use of technology, use of libraries, use of framework, use of code that we're going to create, use of interfaces. So every level we reduce what we want to do. Now, obviously, one fear here is if you focus only on parsimony, what if we create this ball of mud where everything is in one place and tightly coupled? Well, that's where testability still comes in. Parsimony pushes in one direction, testability pushes in the opposite direction, and there's a balance we get out of those. So don't use parsimony alone. You also mix it with automated testing. It will balance out where you can, the nice middle ground. And Ken Beck talks about triangulation. Triangulation is where, and I keep pleading with my developers all the time about it, don't create abstractions and generalizations in the beginning. You instead create the code, make it work. When you need something similar to it, duplicate it. You say, wait a minute, did you just say duplicate it? Yes, I did. Duplicate it. Make it work. And once both of them work, take the two examples that are working and you're like, oh, wait, both of them are working. They serve the purpose. So you have duplicated it. And you may say, gosh, isn't duplication wrong? No, it's not wrong. Only it's wrong when you check it in or when others see it. Well, the point is, it's a temporary journey. So you duplicated it. Now both of the solutions are working. Now see what's common and extract the commonality. That's the triangulation comes in. So you have these two endpoints and you pull what's common to the top, like in forming a triangle. So triangulate the design. Such abstraction and generalization created is a lot more meaningful and practical and useful than the abstraction we create in the beginning. So I always tell my developers, don't start with an interface, end with it eventually. Don't start with a specification, end with it eventually at the architectural level. Well, Pastel's law is the next one. It's been around for a long time. And Pastel's law says, be very conservative about what you receive, rather what you send, and be generous about what you receive. So in other words, this is especially true in the world of microservices we live in. If I make my contracts rigid, when you evolve your side of the data, it's going to reject as it comes into my boundary because my requirements are stringent as to what I expect. Well, Pastel's law says be generous about what you receive. So when a payload comes your way, only look for the parts you care about and don't look at other parts. This is one of the reasons why a very strong XML validation, while it sounded really great in the beginning, is a terrible idea in today's world. So as an example, at a system level, think about this for a minute. We are sending emails and files and communicating with remote systems. And these systems are different systems. Some of them are mainframes, some of them are mini computers, some of them are PCs, some of them are Unix servers, and so on. And yet, more machines are being created like handheld devices. But yet, we are able to communicate across them. Why? Thanks to Pastel's law. Well, so Pastel's law at the system level is about the protocol for information exchange. At code level, if you're creating a function, taking a class as a parameter is really awful because the sender of the data to your function, the caller of the function, is coupled to that particular class, which is your parameter. On the other hand, for example, right, using example here, it doesn't matter what language you are looking at as long as you can think about the contract that you're receiving. So if your inventory says, array list of, let's say books, for example, that is terrible because the sender has to send you an array list. What if you change it instead to a list? Well, this is a notch better because that could be an array list or a linked list. But what if I have a set? Well, you could try an inventory of collection where a collection could be a list or a set. Or even better, you could send an inventory of an iterator, if you will, and the iterator of books. So in that case, as long as I can iterate over your collection, it doesn't matter what the type of the collection is. That's exactly what Pastel's law is saying, is be generous about what you receive. And as a result, you don't have to make your interface brittle and lends itself for better extensibility. Well, two more things to quickly mention. We all talk about reuse. Well, Grady Booth once mentioned, develop a system for use first, then worry about reuse. I'll post it as a challenge to you. Look at frameworks and tools that are out there that are very popular. I guarantee you, the ones that are popular and effective, meaning they are good, are frameworks and libraries created not first as a framework or a library, but they created it and they refactored it several times based on practical knowledge and practical use. And then based on the practical use, they extracted the details to create the library or the framework. Two examples of this are Ruby on Rails and also, as an example, Spring. Both of those are examples of where practically people used these to develop applications. There was use before reuse that made them really popular and powerful. And in that regard, I would greatly emphasize minimize libraries and frameworks. I cannot emphasize this enough. I've seen products go down and fail because developers and architects and leaders were infatuated with technology. So they decided to bring in things that were not necessary, at least not at the time of the product development. So don't get me wrong, I do like products, I want to innovate, I want to bring in dependencies, but I always ask the question, what's the cost of not using a library or a framework, but also what's the cost of using it as well? I was talking to a developer in India actually when I was visiting, and this particular team, the developer said, oh, we are using 150 libraries, packages in this JavaScript application. I said, 150? And he said, matter of fact, he shrugged and showed me the build file with all the 150 dependencies in it. And I looked at him and said, why do you use 150 dependencies? And he said, because we found them. And that is so true. I love this honesty, right? And this is one of the problems we face is we bring in these dependencies. Sometimes this is called RDD, which stands for resume-driven development. People want to use things on their product so they can put them on the resume. What a disastrous situation. I often use this particular rule. When I look at a library that I want to use, I ask myself, how much of that am I going to use? What is the cost of me developing without it? And I time box that effort. If I can put a little bit of time and I can use it without the library, I would want to really build without it because I don't have the dependency in the long run. But if I'm going to use a substantial portion of the library and it's intrinsic to what my application needs, then I will evaluate that library and then bring it in. So to me, integrating a library into a product is not a very trivial pursuit. I spend a lot of time on making the decision, and I want to know very clearly that I've thought through the consequences of building this dependency into my application, because it's always easy to bring it in and incredibly difficult to take it out in the long run. So to summarize what we talked about here, it is extremely important for us to evolve the architecture. Well, we talked about what architecture is a little bit. And when it comes to creating architecture, we don't want to commit to the architecture in the beginning because we don't understand a lot of details in the beginning. We want to take some time and evolve the architecture over the next several sprints in the beginning. We want to create an architectural vision and come back and refine it over the sprints as we gain confidence by way of understanding more about the product we are actually building. And there is risk for not evolving the architecture, being that the architecture may be irrelevant to the application or derail the application from the reality if forced upon. There's also a risk in evolving architecture as well, and we can mitigate that by prioritizing on the business values and the architectural impact, and building in vertical slices and rather than building in horizontal slices. Then we talked about some practices we can follow. One of them being to focus really on keeping things simple, and then to continuously refactor the design and the architecture and throw away parts that are not necessary, rework and make things simpler along the way, and to maybe even bring in other things that may be more relevant than what we have used already. Making decisions, think about reversibility and only bring in decisions that actually make sense. And postpone decisions that can be postponed to know more about it and before making the decisions. And reject ideas that are not relevant, apply the Agni Principle, and defer creating things that are not necessary. When it comes to extensibility, keep a minimalistic approach and make sure that to really practice parsimony and triangulate your solutions for generalization. And make your interfaces really generous to communicate, apply the Paul's law, and use before you reuse, and be very, very thorough in evaluating libraries and framework, and make sure those decisions are really well considered before you bring them in. Well, I hope that was useful. I really wish you the best. Take a look at the schedule to see what other talks are available. There's plenty of really good one. Enjoy the rest of the conference, and thank you so much for your time. Appreciate it.